In this video lecture, we will see shear force diagram and bending moment diagram of this beam. Total length of this beam is 3 plus 3 plus 6 plus 3, that means 15 meter. And at point A, there is vertical AY reaction and horizontal AX reaction. And at point D, there is vertical DY reaction. And loads are at point B, there is clockwise movement 10 kN meter. And at point C, there is downward load of 20 kN. And between D to D there is UDL of 15 kN per meter. First, judge shear force diagram of this beam. Judge shear force diagram, that means this is in this we will not calculate value of shear force diagram. We will see only shape, how shape occurs due to this loading and supports and beam type. And this judgmental shape is correct or wrong also. After calculation we will know this. So first judge this AY reaction goes upward, that means this shear goes upward. Between A to B there is no load, so horizontal line. At point B this movement occurs, but in shear force diagram this movement does not impact any, this movement not do any impact on this SFD. So don't see movement while calculation of this shear force diagram. Go straight. This 20 kN is load, so due to this 20 kN this SFD goes downward. Between C to D there is also no load, so horizontal line. Horizontal line, that means same shear force. And at D reaction is upward, that's why due to this upward shear force goes upward. And this 15 kN meter is UDL, that means inclined line. And at point E there is 0. So this is shape positive, negative, positive. Now for bending moment calculation, before that see deflection of this beam. This beam deflect like this, like due to this 10 kN, like this. So between D to E portion hogging movement generates, and between A to D portion sagging movement generates. See, between A to D deflection is like this, that means sag movement, and between D to E deflection is like this, that means hogging bending moment. So at A movement is 0 because only reactions are there. At point B movement is inclined line. See, movement is like this. In between A to B there is no load, so movement is like this inclined line. And at B clockwise movement, so suddenly increases due to this clockwise movement. So at point C at point C shear is 0, that means movement is maximum there. So again B to C no load, that means inclined line. Here maximum. Again C to D portion no load, so here it is like this incline. D to E is hogging, that means this goes like this, and this is like this hogging negative. This is parabolic curve due to UDL. This is positive. Now calculate reactions. Vertical is positive, downward is negative. So see here, this AY vertical, DY vertical, this 15 kN meter is downward, and it is this 15 kN meter is acts on this 3 meter distance. This 20 kN is also downward. So first convert this 15 kN UDL into point load. So this 15 kN per meter act on 3 meter distance. That means, and conversion of UDL into point load. Where this point load act? It is center of this D portion, like this. That means from D point, distance is 3 by 2. That means 1.5 meter. And 15 into 3, 45 kilonewton point load act on this beam. Now that means positive A by minus 45 minus 20. So AY plus DY is equal to 65 kilonewton. Now take movement at this point, A point. So for that, summation of movement at A point equal to 0. So see, this 10 kilonewton is clockwise to that point. So clockwise, that means positive 10, only movement here. And this 20 kilonewton is also clockwise. So positive, clockwise, that means positive. See here, clockwise consider positive and anti-clockwise consider negative. Clockwise to that point where we take movement, and anti-clockwise to that point where we take movement. So this 10 kilonewton is clockwise to that point. So positive 10. This 20 kilonewton is also clockwise to that A point. So it positive 20 into this force into distance, perpendicular distance up to that point. 3 plus 3, 6. 20 into 6. Now this 45 kilonewton force is also clockwise to that point. That's why positive 45 into distance is this 1.5 meter plus 6 plus 6. 3 plus 3, 6. That means 13.5. 6 plus 6, 12 plus 1.5, 13.5. And see this RD reaction. This RD reaction is anti-clockwise to that point. Yeah, anti-clockwise, that means minus, and dy into, from dy to that point distance is 12. So minus dy into 12 equal to 0. So it is 61.46 kilonewton. Dy is now put this dy in equation 1. So Ay is equal to 65 minus 61.46, 3.54 kilonewton. See why this dy reaction. See, dy reaction is 61.46 and Ay is 3.54. So why this dy reaction comes greater? Because see, this 45 kilonewton is more load, and this more load is towards this point D. That's why reaction is greater at D. So this Ay reaction is nothing but this here 3.54, and shear unit is kilonewton. So here it is 3.54. In between no load. So up to here, up to C point, just left to that C point, similar 3.54 kilonewton. So write shear here. Shear force calculation. Shear force at point A is equal to 3.54 kilonewton. shear force just left to that point C is also 3.54 kilonewton, and shear force just right to that point C is, see this, 3.54 kilonewton and minus 20. So it is minus 16.46 kilonewton. So this value is 16.46, and up to here it is same 16.46 negative. Due to this dy reaction, minus 16.46 plus 61.46. Shear force at D just left to that D is same minus 16.46. But shear force at D in just right to that D is minus 16.46 plus that upward reaction. Upward reaction is 61.46 kilonewton. So minus 16.46 plus 61.46, it is 45 kilonewton. Here 45 kilonewton. Now shear force at just left to that E. Shear force just left to that E is 45 kilonewton minus this 45 kilonewton. So it is 0 kilonewton. So our shape and values are correct. Now calculate moment. Bending moment calculation. First, see support A and support D. Support A have only reactions, so their movement is 0. Unit is kilonewton meter. At point B, now we need to take shear force at this point B. So see left side of that point and see forces, left side forces of that point. So left side forces is only AY. So positive AY that means 3.54 into distance between that force and up to that point. So distance is this 3 multiplied by 3, it is 10.62. So that means this is 10.62, and unit is kilonewton meter. Kilonewton meter. Now up to here moment is 10.62, but see this clockwise 10 kilonewton meter movements. So addition of this clockwise, that means positive 10.62 is this, and plus this 10, so it is 20.62. So up to here it is 20.62. Now consider movement at this C point and see left side forces, this AY 3.54 multiplied by distance 6, and this is clockwise plus 10, that means 31.24 is here. Maximum movement here at this point. Now calculate movement here at D point. So for that D point, see right side forces. Right side force is 45 kilonewton and it is clockwise. That means positive 45 into distance between that force to that D point is 3 by 2. That means 1.5. That means 67.5 is calculated moment. But when we see right side forces, then we change sign. So here minus 67.5. And at point E, there is cantilever end, so it is 0. So our judgmental BMD and values are correct now. So let's see this is in StatPro software also. Unit is metric, create, type is analytical model. Total length of that beam is 3 plus 3, 6, 6 plus 6, 12 plus 3, 15. So first is 0 node, second is 9 meter distance and then 15 meter because one support is at 9 meter. So this is 9 meter and this is 3, 3, 6, 6, 12, this is 12. See, go to utilities, node tools, node to node distance. This is 12 and this is 3 meter. That means total is 15 meter. So at point A there is pin support. First define properties. We will calculate shear force and bending moment only for live load. Material is concrete. Support is pin. Assign this support to that A point. Assign to selected beams. Yes. Delete this pin support because see our analysis is 2D analysis and we need to release this FZ, MX, MY, MZ. Only Fx and Fy reaction comes. So select this, use cursor to assign again, assign, assign. So next at point D there is roller support. So create roller support, only Fy reaction comes, all others are releases. Shift K, then select this support 3, use cursor to assign, assign and assign. Now loading. See at point B. That means from point A, it is 3 meter distance. Concentrated movement 10 kiloton meter act. So 3 meter. Load case detail select. Add loading type live load. Title live load. Add close. Click on live load. Add. Go to member load and then click on concentrated movement. See this. Use thumb rule for see this Z direction arrow, this StatPro Z direction arrow, and take your left hand and your thumb is toward this Z, and your where is your forefinger? Your forefinger is movement here. Thumb rule. If you consider Z X direction, direct your thumb towards X direction, and your forefingers are movement direction. So here GZ, that means this movement is like this. So GZ, and here value is 10 kilonewton meter clockwise. Tad clockwise, that means minus 10, and at a distance of 3 meter. Add close. Select. Use cursor to assign, and click here. Right click, labels, scales, reduce the scale. This is distributed force, but we reduce all scales. Yeah, okay. Now next force is 20 kilonewton at 6 meter from him. Again click live load, add, go to member load, concentrated force of 20 kilonewton, 20 downward, that means minus 20, and D1 is 6 meter. Assign to selected beams, assign, yes, okay. Now next is for that DE portion, 3 meter portion, 15 kilonewton per meter UDL. So live load, add, member load, uniform movement, Y direction and minus arrow because of downward. Add close. Select this beam, assign to selected beam, assign, yes. So see, by mistake we had used this uniform movement. So not uniform movement, uniformly distributed force. See this uniform force, minus 15, Y, add close. Now analysis it. Go to cross processing, apply OK. See, this is deflected shape of this beam. This beam deflect like this. Here see hogging movement and here sagging. And see shear force diagram. See, this shear force diagram is also similar. Our manually calculated is not as per scale. StatPro calculated is as per scale. So it is 3.54, 3.54, 45, 45. Correct. 16.4 by 16.46. Yes, correct. Now see movement. Annotate beam result, bending. Annotate close. So STAD negative, that means STAD negative bending moment, that means sagging bending moment. STAD positive bending moment, that means hogging bending moment. And in our manually calculated positive bending moment, that means sagging bending moment, and negative bending moment, that means hogging bending moment. This is difference. So STAD negative value minus 31.250. This is minus 31.24. This minus 31.225, that means sagging 31.25. This is positive 67.5, that means hogging 67.5. See, this is 67.5. That's why our manually calculated SFD is inverted than StatPro calculated SFD due to sign convention. But values are correct. This way our numerical completes. Thank you very much.